Hello, I'm Mirko. In this video, I will present to you my work entitled Decentralized Systems for the Protection and Portability of Personal Data. I introduce to you the Internet of Person. It can be considered as a logical continuation at an higher level of abstraction that we can comprehend the Internet to be. It means to create a network for an individual and his or her relationships with other individuals, information and communication technologies, and the world around them. The IoP paradigm leverages new information and communication technologies to place their users at the heart of the data management design. This allows to aim for a new self-sovereign identity that allows individuals to regain their digital sense of ease and to foster the development of a new digital identity that is truly representative of their intentions. I'd like to share with you a motto: demand more from your digital presence. This motto is based on three pillars. One is to understand your digital presence. The second is to combine law and technology. The third one is to benefit from decentralized systems and interoperable data. Understand your digital presence means that we have to recognize the data about location, interests, likes, relationships are all small components of a version of our online identity. In this context, from whom are we demanding the most? We are demanding from those who store this data and those who decide what to do with it. So, most of the times, online services providers and social media platforms. In this case, we need transparency in the data management of our personal data that can allow us to really understand who we are online. We said we need to understand our digital presence, and secondly, we need to combine law with technology. The GDPR applies in the EU to regulate personal data processing, as well as the eIDAS regulation for online identity and authentication. The combination of the law with new technologies enables the evolution of smart agreements for the exchange of personal data. In this case, users can set their privacy policies through a new set of technologies called smart contracts, and online platform can allow the access to the user's personal data in accordance with their privacy policies. Finally, we benefit from disintermediation technologies by removing the intermediaries in the processing of sharing our data. To achieve this, we can use decentralized system and interoperable data. Data interoperability means a set of techniques and standards that facilitates the exchange of data between different information systems, whilst decentralized systems we will see in the continuation of this presentation. Now, let's take a look at the Internet of Person data sharing protocol. The user is at the center of this protocol, and as we can see, it can decide directly and can control the sharing of his data. Let's take, for instance, Alice on the right that is willing to access Bob's on the left data. They can interact through their self-sovereign identity. Then Alice can access Bob's data using a set of policies. A system implementing a distributed authorization can release some access key to Alice. Alice can verify the data using a decentralized indexing system and then gets the data from a personal data storage. In the following, we are going to see each of these steps and each of these systems that combines this protocol and this model. Personal data are kept in a personal data storage, which consists of a set of encrypted data referring to the subject and that are stored in a decentralized file storage. Decentralized is in parentheses because it can also be a classic cloud file storage service such as Google Drive, but in this context we were going to focus on the decentralized file storage service such as the IPFS technology. It is important to stress the fact that data is referenced uniquely using hash pointers that are the result of applying an hash function to that piece of data. Then we need the integrity, reviewability, linkability, and indexing of the encrypted personal data storage. In particular, we reference data and their content using hash pointers on a DLT. Then we create a personal information management system based on a DLT that needs to be designed to prohibit or prevent personal data from being stored on-chain or not in a tightly controlled DLT. We follow several guidelines, such as the one from the EU Blockchain Observatory and Forum, and we design a multi-layered DLT with a permissional DLT as the main one. In this DLT, the operators agree on contractual terms that define precisely their roles and duties and the privacy policies towards the end users. These ones are data controllers, obliged to facilitate the exercise of data subject rights and thus becomes data intermediaries. Then, in the other layer, we have the distributed authorization. Indeed, access to the data stored in a personal data storage can be allowed by the data holder through smart contracts. Authorization servers, that are the ones that also manage the permissioned DLT that we've seen in the previous slide, perform on-chain tasks such as smart contract executions, but also off-chain tasks such as keys distribution. Each piece of personal data is referenced in a specific smart contract using its hash pointer. The smart contracts then manage an access control list. An encryption key will be issued to the data recipient listed in the access control list. Then we use policies to enrich the expressiveness of the access control mechanism and to let the data holder express privacy policies to be enacted through smart contracts. We refer to a set of semantic web technologies and standards, in particular the ISO IEC and PEG21 framework, the media contractual ontology, the smart contract for media, and finally the W3C data privacy vocabulary. These standards are used to enforce legitimate data access rights that might take precedence over those of the users, such as the GDPR vital interest legal base for data processing. The link between the operational side of the smart contracts and the narrative clauses of a policy are completely mapped thanks to the use of the above-mentioned standard. In the following, we see an example of a data sharing policy. In particular, we have a data processor, data controller, and data subject. Then we define a specific piece of data and a permission to access that data. In the permission, we have a requirement, which is the consent. And then in the consent, we define the subject, data controller, the purpose of the data processing, and the type of processing. Then we also find the textual clause of the policy that will remain attached to the smart contract execution. Finally, we have a layer that closes the circle of the implementation of the self-sovereign identity and creates a port to let any information communication technology interact with the on-life identity of an individual. We provide a model called intelligible identity, which is a set of technological components that are deployed in a decentralized environment for the purpose of providing, requesting, and obtaining qualified data in order to negotiate and/or execute electronic transactions. In particular, it consists in a specialization of the W3C decentralized identifier standard. The intelligibility is conveyed by linking resources that make up the document or define the legal context of the identity, the agents that are involved in the issuing and the verifying of the identity, and finally, the digital resources that describe how to perform operation with the identities. Finally, through these layers, we define a model of the Internet of Persons in which two or more persons can interact, and also third parties and companies can exploit each layer to get the personal data of a user. Thank you for your attention.